Hi, everybody.
There we
So we're
go.
going to
Yeah.
talk about, hi, it's Judith Weis here, uh, talking about pollution effects on hermit crab behavior. I must say, the research to find the reports that I'm going to talk about, I was not super impressed about the papers. Um, but I think there's a need for a lot more and better research on this. I would also say that the majority of the papers that have been done have been on marine hermit crabs, not land hermit crabs. Many studies on pollution means you put a certain amount of a certain chemical or whatever in the water, and then you have control crabs that are not exposed to that. That's a typical way of setting an experiment, and you really can't do that on land. You can't have a study where crabs over here in this aquarium are getting exposed to an air pollutant and the ones in another aquarium are not. So we've got mostly stuff on aquatic, marine hermit crabs. Anyway, one of the major things that people study is shell, relating to shell behavior, shell use, and how that behavior can be affected by pollutants. The shell is, as I'm sure you all know, a vital thing for a hermit crab. It protects them against drying out. It protects them against temperature and other environmental things. They're protecting basically their soft abdomen. And when they're threatened, I'm telling you what, I'm sure you all know, they withdraw tightly into the shell, protecting the legs and head and eyes and so forth that are ordinarily, sticking out of the shell. Um, Hiding time is another kind of behavior that can be studied. How long are they hiding in there in response to something versus how soon did they come out? How bold are they? Things like that. Um, Shell quality is, as I'm again telling this, preaching to the choir here, to get information about the quality of available shells, and they shall select the shells based on their size, species of snail, which would mean the characteristics of the shell, and if the shell is damaged or not, and its color. The shell
Did you
size is,
did
hello?
you advance the slide?
I have been advancing them.
Yeah, we're only seeing the title. I think you're advancing on the wrong
Oh,
screen.
I have been moving them. Maybe you should do it then. Um,
Okay, let me
on
read.
your side. I've been moving the slides.
Okay, yeah, they aren't showing up for us. So let me, if you want to end your screen share, I'll start mine. Just 1 second. Okay. Yeah, there it went. So now we see the crab emerging after being startled.
But now I'm now down to what you've got, but I can't change the slides on this screen now.
Okay,
So,
go ahead if you want to end the screen share, and I'll share mine, and you can just say next when you want the next slide.
okay. Okay, let's do that.
Okay,
Sorry, everybody.
that's okay. Technology can be challenging. Okay. So there was the first one when you talked about the crab emerging after being
Right.
startled.
Keep going.
Okay, and then that was
We
the
also
behaviors.
covered this. And okay, I think we were on that one. Back up one.
Back up
We
one.
were on one before that.
About
Um,
shell quality.
right, the shell quality. Um, it's critical that it be the right size, and it can affect not only survival, but growth rate, how many offspring they have, and protection for developing embryos. Um, so larger shells are advantageous, but they have also a bit of they're heavier and they require more energy to move. So the best shell is some optimum trade-off between the bigger shell, which is giving better protection, and a smaller shell, which isn't so heavy to carry around, and more energy available for other things. Okay. So this is a picture of fighting, which you've probably seen, and they compete over ownership of a shell. And shell fights uh, are very common and have been studied for behavior. The next slide, I believe, is a short video, which I don't know if you'll be able to show it or not, but take a look at the next slide.
Okay. Oh, so
Yeah,
this is in YouTube.
It's a YouTube video.
Okay, let's see.
If it doesn't work, it's not the end of the world, but if it does work, it's kind of nice. There it is.
Okay, so here we are. These crabs have been isolated for about 16 hours. We're going to use this tank as an arena to stage a fight in. And this large crab is in a shell that's too small for him.
It's uncomfortable.
Yeah, you can see he doesn't really fit in there very well. He's
Yeah.
trying to withdraw.
Sorry, my bad. I was trying to mute myself and it muted the
Okay,
video.
so here we are. These crabs have been isolated for about 16 hours. We're going to use this tank as an arena to stage a fight in. And this large crab is in a shell that's too small for him.
It's uncomfortable.
Yeah, you can see he doesn't really fit in there very well. He's
Yeah.
trying to withdraw, but there's still, the claws are exposed. So let's put him in there. This is a smaller crab, and you can see he's withdrawing right
So
into that
he's
shell.
shaking around in a rather loose coat.
He's got a very, very spacious house. So we've got a big crab in a shell that's too small, and a little crab in a shell that is just right for the big crab.
A large crab adopts intimidation tactics in an attempt to make the smaller crab leave its shell.
It's a little bit like a war of attrition, you know, who can keep going for the longest? Will the attacker wear itself out of the shell wrapping before the defender decides to give up? And here we go.
Here we go.
Hey, an eviction. There it was. So the attacking crab just evicted the defending crab. The attacking crab has gone into the shell that's just pulled the defending crab out of, and it's trying to keep the defending crab. No, the defending crab has now gone into the shell that the attacking crab vacated.
Not putting up much of a fight, I have to say.
No, you're not going to hang around without a shell if you can possibly avoid it.
Hermit crabs are an evolutionary marvel, perfectly adapted to recycle the discards of another species.
I guess that's enough. I think we can move on. Oh, it's a new font. I never saw this font before. This is very strange. Okay, so when one crab is trying to evict another, it generally bangs on the shell with the claw, and the defender remains as far withdrawn in the shell as they possibly can be. And this was a study to see what effect copper, the metal copper as a dissolved toxic chemical, would affect the aggressor who's trying to get the shell versus the defender of the shell. And the results of this study was that if the attacker crabs had been exposed to copper, they started fewer fights. And those that did start fights were less likely to be able to evict the defender of the shell. But this effect varied with the size difference between the shells. They also were hitting the shell less vigorously. If the defending crabs were exposed to copper, there was no change in their behavior. They were not more easily evicted, for example. So that the effect of copper was just on the attacker and not on the defender. Okay, next. Okay, here's a study about microplastic effects on shell behavior. And here was, again, about always marine hermit crabs. They kept the crabs in tanks, either with microplastics, 25 parts per cubic liter, or no plastic. And then they transferred all the crabs into so-so shells, intermediate quality shells, and presented them with a choice of a worse shell or a better shell. And the shells were not actually available. The shells were in vials, glass vials, so the crabs could only see the two choices. They couldn't try them out and for fit. They could just see them. And the results were that the crabs that were exposed to the microplastics were less likely to go toward and hang around by the vial with the better shell, but hung around more by the vial with the worse shell. And they concluded that the crabs' assessment and decision making had been impaired by the exposure to the microplastics. Their cognition had been impaired by exposure to the microplastics. I would have liked to see this experiment done when there was actually possible for the crabs to get into the choice of which shell, but this was not done that way. Okay, next. Okay, this is another study on microplastics where they had some of the crabs exposed to microplastics, and I don't have here the concentrations here, and the control was not. And then each of the crabs was put into a low quality shell, and looking at their ability to choose a better quality shell. But then they, at the time when the crab was coming near the high quality shell, they got startled. I guess the investigators knocked on the table or did something to startle the crab. And the results were, in the microplastics, the females were more likely to enter a high quality shell than females from control. So this is the total opposite. The microplastic, in this case, made them choose the right thing better. And the females spent similar time investigating high quality shells as the males did. The controls is the one without any treatment. The females are more likely to spend time in the low quality shell and spent longer time investigating high quality shell than males. So this has got sort of a very mixed message. It's not very clear. I'm not faulting the researcher, but it's confusing what the crabs did. You know, it's not really very clear answer on this effect. And we don't know here in this case how concentrated the microplastic was, how long they were exposed to it, and a whole slew of other details that probably were pretty important and we don't know about them. Okay, next. Okay, this is another one with looking at startle response. Again, you know, they exposed the crabs to low or high concentrations of microplastics, and then startled them again. And apparently, ones exposed to the microplastics had a decrease in the duration of the effect of the startle. I mean, they became generally less risk averse, that is bolder, and their behavior became more predictable. By reducing a startle response, that might make them more susceptible to predation. A startle response generally means you go hide in your shell, something. And that's adaptive. I mean, if there's a predator coming around or something, the startle response is a good thing to have. It's probably not a good thing to have if you hide in your shell and stay in the shell, for 5 hours or something. But it appeared to be that in this case, reducing the startle response, they might be more susceptible to predation because they're then assuming there's no problem anymore and there might still be a predator around or something. Okay, next. Here's a noise pollution study, and here we're using land crabs, Cenobita, so your favorite crab. And studying noise pollution is easy to do for land crabs, whereas all these other exposures are not easy to do for land crabs. So here they allowed a similar predator to approach, and how long does it take before they hide? And then if they play boat noise, they're going to hide in their shells. But the boat noise question is here, does the boat noise mask the sound of the predator coming, or does it distract the crab? Does it take their attention away from the predator so that they're not responding the way they ought to a predator? And they found there was no support for the first hypothesis because the support was if they made the distraction even worse, adding lights to the boat noise that further distracted the crabs, and they were able, the investigators were able to approach more closely than just with the noise alone. So sound, noise distracts the crab and makes them more vulnerable to predation. This I think was a reasonable study. It made some sense. And the boat by itself, the noise distracted them somewhat, and the boat plus flashing lights distracted them even more, which is logical and makes sense. Next. Another noise pollution. This is back to Pagoras, the marine hermit crab. They attracted crabs with a chemical cue that is like a dead snail. And they measured the number of crabs arriving in the field in silent air, in quiet area to this chemical cue versus when there's a loud noise going on. And so it's a chemical response to a chemical cue, the odor of a dead snail. And you can see in the graph, the control, 5 to 6 individuals showed up to investigate. But in the noise on the right-hand side, when there was noise, far fewer, less than half the number of crabs showed up. So you can say that the noise affected the use of chemical information, which of the animals, their behavior in the field. Okay. And then another one, this is a really complicated and confusing experiment. They were trying to look at 2 different things at once. They were looking at noise pollution and also whether the crabs preferred to be with one other crab or preferred to be in a group. And they put the crabs in either not such good shells or in better shells and exposed them to play of either ship noise or the control was sort of ambient sound, no ship noise, but background, if there's birds chirping or whatever. And also at the same time, did they prefer to be with one or with 5 others? crabs in suboptimal shells, that is, they're probably too small, took longer to go to the area where they had a single crab in an optimal shell. That was seen when there was the control, that's ambient sound, but that was not seen when they had ship noise. And under ambient sound, the crabs in optimal shells, the shells that fit fine, spent most of their time close to a single other crab, while crabs in suboptimal shells showed no such preference. So that's, it's a complicated, confusing experiment. Let's go on to the next one. Okay, we've got one in about light pollution. They have, normally there's daytime and nighttime, but they had some crabs that they kept in constant light, instead of 12-hour light, 12-hour dark, and they found the crabs in constant light was less bold and had a higher metabolic rate than ones that were kept in a 12-hour light, 12-hour dark. They also looked at exposure to light pollution at light, and assuming that they would experience increased perceived predation risk from that, and then reduced boldness could be protective against predators, but could also lead to lower rates of feeding and so forth. So, there's, I guess, it's good to be bold to a degree, but being too bold might mean somebody's going to eat you. But if you're too shy, you're not going to get your food, and you'll have not get enough energy. So too much is not a good thing, and too little is not a good thing. Okay, let's go to the next one. So this sort of summarizes a lot of the thinking in this whole field. The pollutant, it disrupts the use of information and alters the performance. And in general, hermit crabs are good for studying assessment of shells, studying aggressive behavior, studying coping with risks and personality, and how these behaviors are affected by pollutants. And the thing in the middle is showing, how you can look at shell investigation, discrimination between shells, fighting ability, boldness, responses to predators, more or less boldness, shell selection activity, relating to all these different types of pollutants, low oxygen, temperature, ocean acidification, plastic, metals, organic compounds. So there's a whole lot of different stressors have been looked at, and this is sort of summarizing all the sorts of things that have been done. And the hermit crabs are very good, what they call behavioral models, and for studying effects of pollution on behavior and mechanisms of behavior change, that they're very good. I'm a little disappointed at the collection of studies that I was able to find. I mean, some of them were better than others, but I think there's room for improvement in this whole field. I think, is that the last sort of summary slide? Is there anything on that? That's the last one. So yeah, they are certainly impacted in important ways by all sorts of pollutants. And the question is also, how concentrated were the chemicals that they used? Were they anything like the levels of those chemicals in the environment? if you use a huge level, if you're a huge dose of something, and you find the animal is, behaving weirdly, that may be unrealistic because they'll never encounter that much copper or mercury or noise or whatever you do, or microplastic. So it's not clear to me, um, how many of those studies used realistic um, amount concentrations or levels of the stressors that they used. Um, anyway, I'm done.
I'm just looking in the chat to see if you have any questions, so I'll just read those out to you. Jesselyn is asking, are there any studies like being done right now that you're aware of on this topic?
There are some authors who have been working on this, and I have seen lots of papers by those authors. So I'm assuming they're doing further studies now, but I won't know about it until they publish them. But I don't know any of these people personally, but I'm assuming people have been working on it for years, still are doing so. So here's a question. Why might a crab be a bully when all needs are met? I mean, just personality. I think that's true. Just like people, you got some people that are nasty and bullies, even if they aren't being deprived of important things in their life.
Were any of the studies on microplastics related to, I think it was at the Henderson Islands or Pitcairn Islands, where they found the plastic bottles that the hermit crabs had crawled into and then got trapped in there, and as more died, they kept crawling in and kept dying.
Yeah, I talked about that too. Yeah, that was so sad.
Yeah,
that was so sad. I don't know what the question was. Are they still? That's still happening? I don't know.
I wasn't sure if that was part of a study or if that was just an observation that.
That wasn't a study. It wasn't done on purpose. That was just something that was basically like a trap that they kept falling into. Very sad. And here's somebody's a good comment here. Wild versus captive hermit crabs. Yes, that's a very good point. Captive bred hermit crabs are not likely to be behaving the same way as wild ones. And that's true. You think about all the research, the health studies that are done on lab rats and mice, which are not the same as the rats and mice that are out there in the world. And that's a really good question.
Do we know what unpleasant sound the researchers use and what they consider or use as ambient?
One or two use boat noise. And the other, I think they just made a loud sort of crash noise, maybe banging pots together or some loud noise. But one of them was particularly boat noise, which is more likely to be in the environment of hermit crabs than banging metal pots together.
Right. I would imagine ambient sound was probably just water, ocean sounds. How large of a concern is the plastic plants and other? We use a lot of plastic items in our crab habitat. Is that something we should be concerned about? Something we should be trying to move away from?
Well, I don't know if there's an alternative that that you could use. I mean, live plants makes a whole lot of other issues of keeping the plants alive.
Right, and
you have enough thing taking the good care of the crabs. You add on a second thing taking care of the plants. I wouldn't worry too much about the plastic plants. I mean, they'll probably, if the crabs are scrambling over them and walking on them, probably releasing some microplastics. But I doubt that that's, a big worry.
Okay. Big difference. I think that's the last of our questions. Everything else looks conversational. Thank you. Thank you. Everyone's saying thank you.
I wish I could have presented something that I found more exciting than this whole set of studies. Last year, I was much more excited about the stuff I talked to you about a year ago. But
I think this is important, though, too. I mean, it's a growing concern just in general, and how pollution is affecting their environment.
Yeah, I know. But I'm just sharing my personal feelings that this was not as much fun to put together or talk to you about than what I did a year ago. But
well, you have a year to come up with a topic that you're really excited about for next year.
Yeah.
All right.
Start thinking about it.
Okay. It looks like everybody's going to head over to Dr. Tudge, so I'm going to jump off and let you jump off. Thank you. I enjoyed this. I'm sure everyone else did too. All right. Bye-bye.
Thanks, Stacy, for doing the slides.
Oh, sure. No problem.